Okay. So the first question says, the diagram shows a kite OABC in which AC is the line of symmetry. Okay. The coordinates of A and C are 0, 4, and 80 respectively, and O is the origin. Find the equations of AC and OB. Now, obviously, it's basically a kite-shaped figure, and AC is the line of symmetry. Why? Because above the line of symmetry and below the line of symmetry, or on the left side of the line of symmetry or right side of the line of symmetry, the shape is same. Okay. So for example, I'll just quickly explain this concept. If I talk about the circle, this is the line of symmetry, not this, obviously. Wait, let me make something in the center, something of this type. Then this is the line of symmetry, because above the line or below the line and on the left and right sides of the line, the shape is same. Okay, so you guys are coming from O level, so I'm pretty sure you would be knowing that a circle has infinite many lines of symmetry, right? I can make a lot of line of symmetries, and whenever I'll make the line of symmetry, just know that on the right side and on the left side of the line of symmetry, the shape is same, the size is same, and everything is symmetric. Okay, this is what exactly symmetry means. Anyways, the important part is that you have been asked to find the equations of AC and OB. So what we can do is, for AC, obviously that's a line, so it's very easy. For the equation of any line, you need a point lying on the line, so you have 2 points, and then you need the gradient, so you can use this and this, these 2 points, to find the gradient, and then we can easily find the equation. Okay, so if I talk about AC, M is y2 minus y1 divided by x2 minus x1. So these are the 2 points. So it is going to be 0 minus 4 divided by 8 minus 0, and this would give me minus 1 by 2. So minus 1 by 2 is basically the gradient of AC. So let's just write down the equation. It's y minus y1. I'll use 0, 4 as the point lying on the line. So y minus 4 equals minus 1 by 2 into x minus 0. And this is going to give you y equals minus 1 by 2x plus 4, and this is going to be the answer. This is basically the answer for the equation of AC. And what about the equation of OB? Yes, can anyone think about it? How can we find the gradient and everything? How can we find the equation of OB?
Since we've already found AC, so
Yes,
OB, if you cut from O to B,
very
if
good.
you put a line there, it becomes a
Excellent.
particular line
Very
there.
good. Well done. Excellent. Okay. That
So
is very good. Very good. Yes, yes, yes.
the gradient will be 2.
Excellent. This is why this was specifically mentioned, all of this, that it is a kite-shaped figure and AC is a line of symmetry, because at times, whenever the examiner is giving the diagram, it looks like uh, this would be the case. But since we know some properties, and using some properties, we know that the red line or OP is going to be perpendicular to AC. Okay. So this means that the gradient of this line is going to be the negative reciprocal of this. This was minus 1 by 2. So this is going to be 2. And we need a point lying on the line. So we already have the origin. The coordinates of origin are 0, 0. So this way, the equation of OB is going to be very, very simple. For OB, it is going to be y minus 0 equals 2 into x minus 0, and this is going to be y equals 2x. So these are the two answers for the question. Okay, so the first part was very easy, the second part was also easy, but you just need to remember, whenever you come across such a scenario, just know that AC and OB are going to be perpendicular. Obviously, there the names and everything will be different, but I'm just talking about the lines. Okay, these lines are going to be perpendicular. Okay, all right. And also another hint. For instance, you guys did not know about it. Okay, but just know that the only information given is about points AC, and using AC you can only compute the gradient of AC. So this would certainly mean that whatever information is given in the question, you need to use that and somehow find the gradient of OB as well. And the only possibility was to, think about it this way, that the two lines are perpendicular, so the negative reciprocal of -1/2 is basically going to be the gradient of OB. Okay, very good. So I suppose this was correct in for both of you. Okay, let's talk about the next question now. It says, find by calculation the coordinates of B. Okay. The next part is that we need to find out the coordinates of B. All right, now we know a few things, like we were able to find out the equation of AC and OB. And let me just quickly check. Okay, this is a 3-mark question. Okay, so we were able to find out the equations of AC and OB. What we can do is we can solve the two equations simultaneously, and this is going to give me this point of intersection. Now, this point of intersection is basically the midpoint of OB. So once you have the midpoint of OB, can you guys find out the coordinates of B?
Yeah, I did.
Okay, very good. And what about you, Rafe?
Yes, miss.
Did you understand the idea? So are you guys good with the second part as well?
Yeah, it was quite easy, the second part as well.
Okay. Okay. That's perfect. Okay, so we get the idea, and this was clear. Okay, let's quickly just go through the second question that I gave as homework. Okay, now it was saying points A and B have coordinates h and 4h plus 6 and 5h respectively. The equation of the perpendicular bisector of AB is 3x plus 2y equals k. Find the values of the constants h and k. Okay. Now for this question again, since we already have some information about the 2 points, although it's in terms of h, but still, using these 2 points, I can certainly find out the equation of the perpendicular bisector in terms of h. And once I have the equation in terms of h, I need to compare that equation with the given equation to find out the value of h and k. Okay, all right. So I suppose both of you were getting the correct answer. H was 2 and K was 36. Please confirm if you guys were getting this as your answer or not.
Yes,
Otherwise,
ma'am.
I'll do this. Okay, and Rafe?
Yes.
Right?
Yes.
Sorry, say it now.
Miss, I'm saying that I got the same answer.
Exactly. Okay, that's perfect. So this means that this was also clear. And now we are in the position to talk about the new questions. Okay. Again, some parts are easy, some parts are technical. So let's do the entire question. Okay. Acha, this question says a diameter of a circle C1 has endpoints at -3, -5, and 7, 3. Endpoints mean obviously if it's a diameter, the starting point is -3, -5, and the ending point is 7, 3, or vice versa. Find an equation of the circle C1. Now we have been dealing with so many questions of this type where we have the endpoints of the diameter and we have been asked to find the equation. So again, I won't be doing the entire question. We'll quickly discuss. Or maybe you guys can take 2 minutes and solve this and send me your working. I think that would be better because we have been practicing this already. Okay. Yes, please do the first part of the question. I was basically interested in the second part because there's a link in a previous chapter. But for now, please do this question. I'm here, and if you're able, and if you have anything, you can ask me directly. Okay.
Mm.
Yes, anything?
The midpoint is 2 and minus 1. And
Okay,
the equation will be
very good.
minus 2 squared plus y plus 1 squared is equal to 41, I think.
Yes, very good. Well done. That's correct. Okay, I'll just wait for another minute, just so Rafa is able to complete his working as well, and then we'll talk about it.
There's the midpoint I'm getting is 2 and negative 1, and the radius is 6.4.
Yes, okay, 1 second only. Okay, and your final equation is?
Miss, wait a second.
Okay, okay.
So the final equation is 2 minus a whole square plus minus 1 minus b whole square is equal to 6.4 square. Then I'll simplify.
Yes, that is correct. That is like the end part is correct, but you said 2 minus p whole squared, right?
No, Miss A.
2 minus a whole squared. And for the second one, you said?
Okay, Miss, wait a second. I think it is x minus 2, right?
Yeah, it's expanded. Oh yes, that's what I
Okay.
wanted to mention. Okay, yes. Because some students are, they use some other variables according to the general equation, but even in the general equation, x and y are same. For the uh, x coordinate of the center, they have h, and for the y coordinate of center, they have q. Okay, so it should be x minus 2 and then y plus 1 whole square equals 41. Okay.
Mm.
All right, let me just
Okay.
write it down again, just so we are clear with the idea. It should be x minus 2 whole squared plus y plus 1 whole squared equals 41. And you're working, both of you were right. Step 1 is to find the center using these 2 points. How do we find the center? By finding the midpoint of these 2 points. And then you'll use the distance formula to find the distance between the center and any of these 2 points. That is basically going to give you the radius, and then you'll do radius squared here, and that is going to be the answer. Very good, excellent. Okay, so this is going to be the equation of C1. Okay.
Mm.
All right, for the second part, now this is important. It says the circle C1 is translated by 8 4 to give circle C2. So initially we were able to find out the equation of C1, and then we translated C1 by 8 and 4 in translation, we shift things. So it has been moved 8 units above and 4 units to the right, as shown in the diagram. Find an equation of the circle C2. Okay, this is what you need to do. You need to find an equation for the circle C2. Now, this time around, you don't have the coordinates of diameter. You do not have anything. You are supposed to use this only and then do your working. Let me just write down the initial equation. So it was x minus 2 whole squared plus y plus 1 whole squared equals 41. This is the equation of C1. And if I talk about the translation vector, so this gives you information about the x coordinate and this gives information about the y coordinate. Okay. So yes, what do you guys think? How would the equation be modified in order to make it for C2?
I think I've done a similar question in edX. So if it is translated to like for x, I think we take I mean, we still have our coordinates, our midpoint coordinates 2 and minus 1. And we simply add them to, to the translation vectors to
Yes,
find,
okay.
to find the center of C2, which can become 8 plus 2 and becomes 10. And the other one, which was minus 1 plus 4 for y. So our vector, our C2 vector, coordinates will be 10 and 3. Then
Very good.
find the code, since we have already, our radius is already R2.
Exactly.
It remains
Yes.
R2, yeah.
Yes, very good. That's very, very right. Very good. Excellent. Okay. All right. Okay. So basically, that is also correct that you think about it this way, that if let's say this was the center, it was 2 and minus 1. This was the center. So when we will move the center 8 units to the right and 4 units above, so either you can think about it logically that when you will move it 8 units to the right, for now it is 2 and then it would be somewhere here and it would become 10. And when you will move this point 4 units above, so this would basically, for now it is at minus 1 and it would come at 3. You can think about it this way as well. And if you just want to use the logic, so this is how we studied. If you don't want to think about it this way, and if you want to talk about translation vector only, we know that whenever something is moving to the right, the change is going to be in x. And in the translation vector, we will get to see the exact change. For example, if something is moving to right in the translation vector, it would be positive 8. If something is moving above in the translation vector, it would be positive 4. But actually, in the equation, it was a bit different for x, if you guys remember, okay? So here, it would be, 1 second. Okay. So we were basically adding things in x. When you're moving it 8 units to the right, this would become x minus 8. And then we already had a minus 2 here. This is what it would be. Plus y plus 1, this is the old one, equals 41. Okay, I missed something on purpose. Now here. Now, usually when we used to talk about the change in y according to the translation vector, for example, let's say this is my parabola and this is the translated version of it. So I have moved it 2 units above. Okay. So in the equation, it used to be x squared plus 2. This is how I used to write it down, okay? But if you look at this 2 was not directly coming with y. This 2 was basically being added in the function. So if I want to see the change, or if I want to see how exactly the equation would look like when I bring the change with y, so that would have been y minus 2 equals x squared. So from the very beginning, the rules were same. Just like when I was moving anything 8 units to the right, I was doing x minus 8. Similarly, when I'm moving anything 4 units above, if I'm writing it on the right side of the equation, I would write down positive 4. But if I need to show that change with x, I will write it down as minus 4. Okay, it is going to be minus 4. Like the way we explain and the way we study this topic is just this, that whenever something is happening along the y-axis, nothing weird is happening. If we are moving the parabola 2 units above, we are adding positive 2. But just look at this positive 2. We were not adding this positive 2 with y. We were adding this positive 2 in the entire function. If I will do that with y, it would be minus 2. Similarly, if I am to show this positive 4 change with y, I will write it down as y minus 4. And finally, this would become x minus 10 whole squared plus y minus 3 whole squared equals 41, and this is going to be the equation for C2. Yes, now tell me if you guys were not able to understand anything.
Miss, I didn't
Yes?
get how the number changed from -8 to -4.
No, wait. Minus 8 to minus 4? Sorry, I didn't get this. Minus
Miss,
8
in that, why -4? Why isn't it y -8?
because this is for x, right? Like this 8 is
Okay,
for
okay, okay.
change in x. Okay, yeah. I said wrong in the beginning. Like I said, it is moving 8 units above. I was wrong. This is basically the change in along x-axis, and this is the change along y-axis. Okay, this is why it is like this.
Okay, Miss, got it.
And are you guys clear with this thing? Like with
Yes.
y minus 4? Okay. All right, perfect. Okay, let's talk about the next question. Okay, now the next next part says, the two circles intersect at points R and S. Show that the equation of the line RS is y equals minus 2x plus 13. Now, let me just scroll up. Okay, that is certain. And that is obvious. This is R and this is S. So we are going to solve the two equations simultaneously. We have the equation for C1, we have the equation for C2. We can find the coordinates for R and S. And once we have the coordinates for R and S, we know how to find the equation for this line. Okay, this would be easy then. Like you are only supposed to find the gradient, and you're just going to use a point lying on the line that can be R or S, and then you guys would be able to find it very, very easily. Yes. So can you, yes,
Miss,
yes.
Miss, can you tell me the variant of this paper, because I
Okay.
need to draw the diagram.
1 second. Okay. Let me just take that out.
Or Miss, you can add it in the group later on.
Okay, okay, okay. No, I want you guys to find the coordinates of R and S right now, so it's okay. I can share the entire thing again. That's not an issue.
Miss, we are going to equate them, right?
Sorry, say it again.
Miss, the question is asking for the coordinates of R and S. So we are going to equate both equations.
Yes, yes, that's right. That's right. You're going to equate both the equations and then, solve them simultaneously. So yes, here are both the equations for C1 and C2. You need to, whatever method you're comfortable with, I don't mind any method. Just try finding out the coordinates of R and S, because this is something I've noticed students are not very, comfortable with this. And for some reason, they are not able to do it directly. So yes, just spend some time, take 3 minutes or 2 minutes, maybe I'm here, and try solving this entire question. Okay, you can find the coordinates first and then find the equation, or you can do something else as well. Okay, meanwhile I'll just take that out and I'll send you, and I'm here. I'm just adding something to the diagram just so you guys can think in the right direction. The center was 2 and -1, and then this center was 10 and 3. The goal is to find out the equation of RS, whatever method you're comfortable with.
Okay. I think what I'll do, yeah,
Mm,
I will take the equation of R, right, and substitute Y
okay,
in -2x plus x. Then on the other side, I'll have my two equations. Then S, which is x minus 2 squared plus y plus 1 is equal to 4 to 1. Then I will expand
mm-hmm.
each equation. Then later I think what I'll do, I'll cancel I'll just cancel the like terms in each equation.
Good, good, yes.
Mm, I think I'm left with, on one side, I'm
Mm,
left with minus 20 plus 4x plus 109, and the other side 6y plus 2y plus 9. So if I
good, 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 yes.
minus 15 plus 109, 8y plus 5, then I put them together. So it's 0 is got minus 16x minus 8y plus 104.
Excellent. Very well done.
Then, yeah, then 8y is got minus 16x plus 104. Then it becomes, we get the same equation that we need to prove.
Very good. Yes, that is correct. Very good. Well done. Yes, that equation is also given. This method is 100% correct. Like you equated C1 and C2, you simplified, you cancel out the square terms, and you were left with a linear equation, and that turned out to be the same equation you wanted to prove. That's 100% correct. Okay. So this is method one. And then we have another method. Let's see. I'm just waiting for Rafe. Let him complete and then we'll see if his method is same like yours or if he has a different method.
Miss, I'm getting 2x plus y minus 13 is equal to 0.
Yes, that is correct. That is correct. Like when you will simplify this, you would get y equals minus 2x plus 13, right?
Yes, miss.
And what was your method? Like, did you use the same method?
Yes, miss. I equated them. Miss, we
Where,
can solve it simultaneously, right?
yes, like this is what you did, right? You just equated them in order to, just simplify it. And then when you were simplifying, the square terms got cancelled and you were left with x and y. And after full-fledged simplification, you got this desired equation. Is it right?
Yes, miss. Miss, can you show me the question itself so I can note it down?
One second. The questions, the second, like this part.
The part C. Yes, miss. I need to write the question.
Okay, don't worry. I can send this on group as well. Wait, one second. Let me just send.
Okay, miss. Done.
Okay, I wanted to talk about the second method of doing this question because I agree if you guys are able to do it through one method, that's fine, but we need to know multiple ways. Okay, so I mentioned the centers and everything just so you guys could think in that direction as well. But honestly speaking, this is more difficult compared to the method you guys preferred. So let me explain this. Okay, now
Mm.
in the question or in the diagram, we have two known centers of the circles, and then we have
Mm.
this line. So again, in coordinate geometry, we will be applying a lot of rules and everything, and I'm pretty sure you guys would have forgotten a few. So that's the best thing about coordinate geometry. Even if you are not sure about the properties, still using some other method, you guys would be able to do it, okay?
Okay.
If I connect the two centers,
Mm.
the two centers, the line that I made by drawing the two centers is basically the perpendicular bisector for RS. It is going to perpendicularly bisect the line RS. It doesn't look like the way I've made it, but imagine if you have two circles with some intersection. So we have circle one. Oh, this is not a circle. We have a circle, and then we have another circle, and you need to find out the equation of this part, and you know the two centers. This is center one, this is center two. When you will connect these two centers, the yellow line is always going to be the perpendicular bisector of the red one. So since, or you can think about it other way around as well, that the red line is the perpendicular bisector of the blue line, okay, in this scenario.
Mm.
So we know how to find out the equation of perpendicular bisector very, very easily. I
Mm.
could have used the two centers to first of all find out this midpoint of both the lines technically, and once I have that um, midpoint, I would have a point lying on the line RS, and for the gradient I can just use the two centers, find the gradient, and for the gradient of RS I'll just find out the negative reciprocal of the gradient of the blue line, and that would give me the gradient of the red line. So both the methods are correct, and if you look at the marking scheme, you would find both the methods, right? And I'm not sure if it was this class or if it was some other class. And marking scheme, the examiner tries giving as many solutions as he can, but still if there's some other method through which that is logically correct, and through which if you guys are able to solve the question, that would also be fine. It could be that it's not there in the marking scheme, but if it is logically correct, and if you're getting the correct answer, that is also going to be uh, a correct method, okay? Yes, so any questions through this method, anything that you guys were not able to understand? Yes, Munja and Rafe.
I'm okay. I did understand that. Thank you.
Okay, and Rafe, what about you? Were you able to? Yes.
Miss, if they ask for the coordinates of R and S, then we would use simultaneous equation, right?
Yes, once we have the two equations, in that case, you'll have to use the simultaneous equations in order to find out RNS. Yes, that's right.
Okay.
Okay, all right. So, um, one second. This question had a D part as well. Let me just quickly take up the D part. Yes. Okay, I got the D part and I am just going to write it down somewhere here because I did not add it over here. Okay. The D part of the question was hence show that the x coordinates of R and S satisfy the equation 5x squared minus 60x plus 159 equals 0. So this is just a 2-mark part and you need to show that the x coordinates of R and S satisfy the equation 5x squared minus 60x plus 59. Okay. So this is basically going to be the next thing. All right. And for this, this is basically the equation of RS. Okay. So that's already used and hence means that you need to use the previous part and every other thing is right here in front of you. Yes. So what do you guys think? R and S are basically lying on the circle, right? The coordinates of R and S are lying on both C1 or C2. So if we consider C2, you can consider C1 as well. That's also fine. If we
Okay.
consider C2, we know that R and S are 2 points lying on the circle. Okay. So if 2 points are lying on the circle, they should satisfy the equation. The equation of C2 turned out to be this one. And the x coordinate is going to remain the same, and for the y coordinate I am just going to plug in this y over here, and when I will simplify I am going to get the desired quadratic equation. Are you guys getting this? Just follow these three things. We have
Yes.
equation of C2, we have equation of the line RS, and I need to show this. Hence always means that you need to use the previous part. Okay, so what I can do is I can just consider the equation of C2 x minus 10 whole squared plus y minus 3 whole squared And this thing is equal to 41. Okay, now this thing right here, what I need to get only has x in it. Okay, so somehow I need to get rid of y. So I'll write it down this way, x minus 10 whole squared plus, instead of y, I'll use this thing. And it's minus 2x plus 13 minus 3 squared equals 41. And when you will simplify this equation, you are going to get 5x squared minus 60x plus 159, and this is what we had to prove. Okay, so you can just simplify it, try simplifying it, you would certainly get this yellow encircled equation. Okay, so this is basically the idea for the last part of the question. Yes, anything that you guys were not able to understand, any query?
No, miss.
Munja, what about you?
No, miss, thank you.
Okay, welcome. Let me stop the recording.